Next is RC filter. As we are already seen, in LC filter there is a series inductor, and that series inductor is replaced by this series resistor. So this filter becomes RC filter. So here there is a series resistor is connected in RC filter, and see here, this is this section 1 of this RC filter, combination of the resistor and this capacitor, and this is this second section of this RC filter. See here, there is a resistor and capacitor. This RC filter is also called as capacitor input RC filter. This RC filter is also called as capacitor input RC filter, and this resistor R is having resistance. This resistor R is having resistance 10 times greater, 10 times greater than the reactance, of capacitor C, and that reactance is Xc. So the resistance of the resistor R, if we consider resistance of resistor R is R, it is 10 times greater than the reactance of the capacitor, that is denoted by Xc. So the resistance of resistor R is 10 times greater than the capacitive reactance Xc. As the resistance of resistor is 10 times greater than the reactance of capacitor, that is Xc, because of that, or therefore, the ripple is dropped. Across R, across resistance R, instead of the load resistance RL. So see here again, as the resistance of resistor R is 10 times greater than the capacitive reactance or a reactance of capacitor Xc, because of that, or therefore, the ripple is dropped across the resistor R instead of the load resistance RL. As the ripple is dropped across resistor R, then each section reduces the ripple by a factor of at least 10. So see here in this circuit diagram, there are two sections here. As the resistance of this resistor R is 10 times greater than the capacitive reactance or the reactance of capacitor Xc, because of that, each section reduces the ripple by a factor of at least 10. Therefore, AC components are removed by this RC filter. So as each section reduces the ripple by a factor of 10, therefore AC components are removed by this filter, means this RC filter. Next we will see the advantage of this RC filter. The only advantage of this RC filter is suitable for large load resistance. RC filter is suitable for large load resistance. Next we will see the disadvantages of the RC filter. The first disadvantage of RC filter is RC filter having poor voltage regulation. RC filter having poor voltage regulation. The second disadvantage of RC filter is there is a loss of DC voltage. There is a loss of DC voltage across the resistor R. See here, this resistor R. See in this circuit diagram, across this resistor R, there is a loss of DC voltage. The third disadvantage is it requires ventilation. It requires adequate ventilation to conduct away the heat produced in the resistor. Conduct away heat produced in the resistor. So third disadvantage of RC filter is there is adequate ventilation requires to conduct away the heat produced in resistor. So these are the disadvantages of RC filter. And finally we will see the output waveform of this RC filter. See here, this is rectifier output, which is pulsating DC voltage. Now see here, this is filter output here. In this filter output there is a reduction of ripples. That means the AC components are reduced here, and this filter output, it gives almost a constant DC voltage. Almost a constant DC voltage, but it is not a regulated. It is not a regulated DC voltage. So RC filter, it will also give a almost a constant DC voltage, but it not gives the regulated DC voltage. So this is the waveform of RC filter, and this is all about the fourth type of filter, that is RC filter. Next is concept of regulation. A DC power supply with transformer, then rectifier and filter. A DC power supply with transformer, rectifier and filter, it provides a DC supply. It provides a DC supply, but this DC supply that is provided by the DC power supply with transformer, rectifier and filter, this DC supply having a poor regulation. This DC supply having a poor regulation. So because of that, this DC supply is called as unregulated. This DC supply is called as unregulated power supply. Why? Because this DC supply which having a transformer, rectifier and filter. This DC power supply provides a DC supply with poor regulation. So a DC supply with a poor regulation is called as unregulated power supply. Why this DC supply with poor regulation is called unregulated power supply? Because the DC output voltage across load resistance RL, reduces with increase in load current, and this DC output voltage, it changes with the change in the AC input voltage, Because of these two reasons, the DC power supply is having poor regulation, and this DC power supply with poor regulation is called unregulated power supply. Therefore, to maintain the constant or regulated voltage, across the load resistance RL, when there is a change or variation in either AC input voltage, or load current, voltage regulation is necessary. So this is the concept of the voltage regulation, or this is the concept of the regulation. See here again, there is a DC power supply we will get from the output of filter. That DC power supply is having a poor regulation. So the DC power supply with poor regulation is called unregulated power supply. Why it is called unregulated power supply? Because the DC output voltage across the load resistance RL reduces with increase in load current, as well as the DC output voltage changes with change in the AC input voltage. So because of that, we have to maintain the voltage, the DC voltage, constant or a regulated. So to maintain the constant or regulated voltage across the load resistance RL, when there is a change or variation in either AC input voltage or the load current, the voltage regulation is necessary. So this is the concept of regulation. नेक्स्ट आहे कॉन्सेप्ट ऑफ रेग्युलेशन. तर इथे रेग्युलेशन कशाला बोलतात, तर आपण बघितलंय डीसी पॉवर सप्लाय विथ ट्रान्सफॉर्मर, रेक्टिफायर आणि फिल्टर ही काय प्रोव्हाइड करते, तर डीसी सप्लाय प्रोव्हाइड करते. पण जी डीसी सप्लाय आपल्याला फिल्टरमधून मिळते ती डीसी सप्लाय काय असते, ती कॉन्स्टंट नसते. कॉन्स्टंट नसते. मग ती जर डीसी सप्लाय कॉन्स्टंट नाहीये म्हणजेच काय आहे, तर पुअर रेग्युलेशन आहे त्या डीसी सप्लायचं. मग जी डीसी सप्लाय आहे विथ पुअर रेग्युलेशन त्यालाच आपण काय बोलतो, अनरेग्युलेटेड पॉवर सप्लाय. त्यालाच काय बोलतो, अनरेग्युलेटेड पॉवर सप्लाय. म्हणजेच हे अनरेग्युलेटेड पॉवर सप्लाय का आपण त्याला बोलणार, म्हणजे जी डीसी सप्लाय आपल्याला मिळते त्याचं जर व्होल्टेज रेग्युलेशन जे आहे ते पुअर असेल, म्हणजे त्याला आपण पुअर रेग्युलेशन इथे बोलतो, त्या पॉवर सप्लायला अनरेग्युलेटेड पॉवर सप्लाय बोलतात. तर ही अनरेग्युलेटेड पॉवर सप्लाय काय असते, ज्या वेळेला डीसी आउटपुट व्होल्टेज जो आपल्याला अक्रॉस लोड रेजिस्टन्स आर एल मिळतो हा रिड्यूस होतो, ज्या वेळेला लोड करंट इन्क्रीज होतो, किंवा डीसी आउटपुट व्होल्टेज ज्या वेळेला चेंज होईल विथ चेंज इन एसी इनपुट व्होल्टेज, म्हणजे इथे आपल्याला डीसी आउटपुट व्होल्टेज कॉन्स्टंट मिळतोय का, नाही मिळत आहे, तो चेंज होतोय. म्हणजेच रेग्युलेशन काय झालं, पुअर झालं. म्हणजेच ती डीसी पॉवर सप्लाय कुठली आहे, अनरेग्युलेटेड पॉवर सप्लाय. तर अनरेग्युलेटेड जी पॉवर सप्लाय म्हणजे अनरेग्युलेटेड जे आपल्याला व्होल्टेज मिळते ते ह्या दोन रिझनमुळे मिळतं. पण आपल्याला जर का ह्या अनरेग्युलेटेड पॉवर सप्लायला म्हणजे अनरेग्युलेटेड व्होल्टेज जे आपल्याला मिळते त्याला जर आपल्याला कॉन्स्टंट और रेग्युलेटेड व्होल्टेजमध्ये मेंटेन ठेवायचं असेल तर व्होल्टेज रेग्युलेशन नेसेसरी आहे. पण जर का आपण व्होल्टेज रेग्युलेशन केलं, पण व्होल्टेज रेग्युलेशन केल्यानंतर जर का एसी इनपुट व्होल्टेज किंवा लोड करंट चेंज जरी झालं किंवा व्हेरी झालं तरी सुद्धा जो तुमचा आउटपुट डीसी व्होल्टेज तुम्हाला मिळतोय तो व्हेरी होणार नाही, तो कॉन्स्टंटच राहील. तर हा ॲडव्हान्टेज आहे रेग्युलेशनचा, म्हणजेच व्होल्टेज रेग्युलेशनचा. जरी एसी इनपुट व्होल्टेज किंवा लोड करंट चेंज झालं आणि जर तुमची पॉवर सप्लाय रेग्युलेटेड असेल तर त्या पॉवर सप्लायचा जो आउटपुटला आपल्याला डीसी व्होल्टेज मिळतोय तो चेंज होत नाही किंवा व्हेरी होत नाही. तर हा व्होल्टेज रेग्युलेशनचा ॲडव्हान्टेज आहे. म्हणून डीसी पॉवर सप्लायमध्ये व्होल्टेज रेग्युलेशन नेसेसरी आहे. तर ही झाली कॉन्सेप्ट ऑफ रेग्युलेशन.